Okay, moving on to question 6. So that was this table here. Look at this table showing boiling points for some substances. So you've got the name of the substance as boiling point and the bonds or the forces that are broken at the boiling point. Now remember, in the previous question, if you're thinking about boiling points, you're thinking about what intermolecular force or other bond has been broken. Okay, so the first one's done for you. Sodium, so we know that sodium is a metal, okay, and all metals have metallic bonding, so that one's easy. Neon, well, neon, if we look in our periodic table, is a noble gas, and we know that the noble gases are monatomic, so they just exist as wee neon atoms floating about, okay? Don't bond to anything. So they must have a force that holds them together, okay? And that force for the noble gases is always LDF because they're non-polar, okay? So for neon, you see how it's got a much lower boiling point of 27, well, it's in kelvins this, so it'll be minus whatever degrees Celsius. So the bonds or forces broken when you try to boil neon would be LDFs. Water, okay, so water, if you just draw water out, okay, so if you think of your water molecules, first thing you would do if you've got a molecule is you firstly decide is it polar or non-polar, okay, and we know already from previous videos that because there's a difference in electronegativities between oxygens and hydrogens and due to the shape of it, water molecules are polar, okay? So they're polar, and the only intermolecular forces in polar molecules are either PD-PD or hydrogen bonding. Now, for a water molecule, because it's got oxygens and hydrogens, it would be hydrogen bonding. Okay? So when you try to boil water, you're not breaking these bonds here in the molecule, which are covalent bonds, you're only breaking the intermolecular forces, which are the hydrogen bonds. Okay, so B should be hydrogen bonding. Moving on to 7. So 7.1, identify the substance which has neither covalent or metallic bonding. So NH3 is made up of nitrogens and hydrogens, both non-metals, so that would contain covalent bonding. Same with CCl4, carbon and chlorines are non-metals, so it would contain covalent bonds. Helium is a noble gas, doesn't bond to anything. The only forces of attraction that hold helium atoms together would be LDF. So it doesn't contain covalent bonding and it doesn't contain metallic bonding, so that would be correct, your helium. Okay. Hg is mercury, and mercury is a metal, so therefore it would have metallic bonding. H2 is a hydrogen molecule. Hydrogens are non-metals, so they have covalent bonding. And HBr would be covalent bonding as well, because hydrogens and bromines are non-metals. Okay. 7.2, identify the substance which is hydrogen bonding between the molecules. Well, remember, hydrogen bonding occurs between hydrogen and either nitrogen, oxygen or fluorine. So NH3, you've got hydrogen and nitrogen, so that would contain hydrogen bonding between the molecules. Okay, and it would look like that. So if you think here, NH3, okay, you would first decide if it's polar or non-polar, and your nitrogens would be negative, your hydrogens would be positive. So it would be polar because of the shape of it, and your hydrogen bond would happen between a hydrogen and the nitrogen in another molecule. Okay. CCl4 would not contain hydrogen bonding because it doesn't have hydrogen, oxygen, nitrogen or fluorine. Neither would helium, neither would mercury. Hydrogen, a hydrogen molecule, I'll just do it in red. Hydrogen molecules are non-polar. Therefore, the only intermolecular force between them is LDF. It's not hydrogen bonding because it's hydrogen has to bond to either nitrogen, oxygen or fluorine, not itself. Then lastly, HBr, well, no hydrogen bonding there because there's no nitrogen, oxygen or fluorine. 7.3, identify the substances which are polar molecules. So we've already talked about NH3, it's polar, so that would be correct. CCl4, I'll just do for you here. So CCl4 is tetrahedral. Okay, and remember, if you've got a tetrahedral molecule where the centre atom is completely surrounded by the same element, it's always non-polar. Okay, so it can't be that one. He, well, He is just helium, and that's not a molecule because it doesn't bond to anything, it's just on its own, so it can't be that. Hg is mercury. Mercury is a metal, so remember, when you see the word molecule, you're only thinking of non-metals, so it's not mercury because that would contain metallic bonding. H2, we've already talked about. H2, because H2 is made up of the same element, it is non-polar. And then HBr. So hydrogen is 2.2. Bromine, if you go to page 11, is 2.8. So therefore, you've got your positive side and your negative side, and it's linear, so you can split it down the middle. So therefore, hydrogen bromide is polar. So that one as well. 7.4, identify the substance which has polar bonds but is a non-polar molecule. Right, here's my... So the first one, NH3, we've already done. It contains polar bonds, right, because your hydrogens have an electronegativity of 2.2 and they're all bonded to a nitrogen which has electronegativity of 3. Okay, so the molecule does contain polar bonds, and then we decided that because of the shape of it, trigonal pyramidal, because you've got a negative side and a positive side, it would be polar. Okay, so it's got polar bonds and it is a polar molecule, so that would not be our answer. Moving on to CCl4, so we're looking for something that's got polar bonds but is overall non-polar. So CCl4, I've drawn here. Carbon's electronegativity is 2.5 and chlorine's electronegativity is 3. Okay, so the molecule does contain polar bonds because your carbon would be positive and all your chlorines would be negative because they've got the higher electronegativity, right? But because of the shape of it, because it's tetrahedral, and your carbon is completely surrounded by chlorines, it would be overall non-polar. So that would be correct. CCl4 has polar bonds but is overall a non-polar molecule. Helium, again, isn't a molecule, so that's not correct. It's just an atom. Mercury is a metal, so that doesn't apply. Hydrogen molecules, we've looked at them. Where were they? Here. Hydrogen has the same element, same electronegativity, so it doesn't have a polar bond, and overall it's non-polar. So it can't be H2. And then finally your HBr, we did that as well. HBr has a polar bond because there's a difference in electronegativity, and look at the shape of it, it is a polar molecule. So that wouldn't be correct. Okay.